We'll now look at multiplying matrices, and we'll start by multiplying matrices in vectors. So, erase some things here. We multiply a matrix A times a vector X by multiplying the first entry in the vector X by the first column of A, the second entry in the vector X by the second column of A, and continue this process, and then we'll add the results. And it's important to note here that we need the number of entries in the vector to be equal to the number of columns in the matrix. If we don't, we're going to have either a leftover column or a leftover entry that doesn't get multiplied by anything. We'll do this example. If I want to find A times X, I would take the first entry of X, which is a 1, and multiply it by the first column, 6, 7, 2, 8. The second entry in X is a 2 times the second column, -1, 2, minus 2, minus 2. The last entry is a -7 times the third column, -4, 1, -5, 4. And then we can just perform these operations. And we do this. We can do it in several different ways. I could do my scalar multiplication and then do addition, or I can do what I'm about to do and combine them all together. I have a 1 times 6, which is 6, a 2 times -1, which is -2, and then -7 times -4, which is 28, which gives me a 32 in the first entry. My second entry, I have a 7, a 4, and a -7, which will give me 4. My third entry is a 2 minus 4 plus 35, which would be 33. And then finally an 8 minus 4 minus 28 is -24. So here is the product. Now that we know how to multiply matrices and vectors, we can multiply two matrices. And we're going to look at two different methods to do this. The first involves what I just did. My new matrix is going to be A times the first column of B, A times the second column of B, etc., up to A times the nth column of B. And this only works if A is m by n and B is n by p. So we need these two numbers to match. Let's multiply here. The first thing we need to do is do A times the first column of B. So I would have -2 times column 1 of A plus 1 times column 2 plus 4 times column 3. And when we work this out, the first entry, I have 6 plus 5 plus 28, which would be 39. For the second entry, I have 0 plus 0 minus 8. I now need to do this for the second column. The second column is 8 times -30 plus 0 times 50 plus 7 times 7 -2. Working this out would be -24 plus 0 plus 49 is 25. And then the last entry, 0 plus 0 minus 14. We then need to repeat this for the third column of B. 0 times -30 plus 4 times 50 plus 3 times 7 -2. This time I have 0 plus 20 plus 21 gives me 41. And then I have 0 plus 0 minus 6. And now we combine this all into one big matrix. the first thing we got was 39 minus 8. So when I have my actual product, my first column is 39 minus 8. Going back, the second thing I got was 25 negative 14. That corresponds to the second column. Finally, my third column said 41 negative 6. So the third column of the product will be 41 negative 6. This seems very tedious, so we do have a second method of multiplying matrices, which essentially does the same thing, but it kind of makes it all combined into one single step. To do this, if I want to find C sub ij, where A times B is equal to C, we'll multiply row I of A by column J of B, and then we add the results. Once again, row comes first, and then column. And here's our example. I'm going to start, the first thing I want is the first row, first column, so I'm going to multiply the first row of A by the first column of B. This is a 1 and a negative 2, which would be negative 2. Negative 3 times negative 5 is 15. And then 2 times 2 is 4. When I add up those three numbers, I get 17. The next thing I'm going to do is multiply the first row of A by the second column of B. 1 times negative 2 is negative 2. Negative 3 times negative 5 is 15. And 2 times negative 4 is negative 8. Adding those numbers up gives me 5. I now do the first row, third column. 1 times 3 is 3. 3 times negative 3 is negative 3 times negative 3 is 9. And then 2 times negative 8 is negative 16. Adding those numbers up gives me negative 4. And now I'm going to move to my second row. The second row of A times the first column of B. Negative 9 times 2 plus 6 times negative 5 plus 1 times 2 is 10. Second row of A times second column of B. Negative 9 times negative 2 plus 6 times negative 5 plus 1 times negative 4 is negative 16. This second row, third column, negative 9 times 3 is negative 18. Negative 9 times negative 3, which is negative 27, plus 6 times 3, negative 3, plus 1 times negative 8 is negative 53. Finally, the third row. Third row, first column, 9 times negative 2 plus 5 times negative 5 plus 6 times 2 is negative 31. Third row, second column, 9 times negative 2 plus 5 times negative 5 plus 6 times negative 4 is negative 67. And then finally, third row, third column, 9 times 3 plus 5 times negative 3 plus 6 times negative 8 is negative 36. So I now have my product. There are a few things we need to watch out for with matrices. One of the most important ones is that AB is not necessarily equal to BA. I cannot change the order of multiplication. And this comes from the way we multiply rows by columns. If I switch the order, I'm no longer multiplying the right row by the right column. The second thing is if I know that AB is equal to AC, that does not mean that B is equal to C. So I can't just divide by a matrix. In addition, if we know that AB is equal to 0, that does not imply that A is equal to 0 or B is equal to 0. So I no longer have my zero property principle. I cannot just say that since the product is 0, one of these matrices had to be 0. And finally, we'll end with some properties. First, even though I can't change the order of multiplication, I can move around parentheses. A times BC is the same thing as AB times C. Distributive properties hold, but you do have to be careful. Since A is on the left of the parenthesis, it should be on the left of the multiplication on the right, AB plus AC. If I switch the A to be on the right side, this is now B times A plus C times A. So we do have to keep straight whether our multiplication is on the right or the left. Finally, if I multiply a product by a scalar, I can multiply by the scalar first and then do the matrix multiplication, and that works if I multiply by either matrix.